Hi, I'm Chris from Glad Science, and I'm glad to see you. The periodic table is an iconic and central figure in the field of chemistry, and it is one that you need to know inside and out. So let's start with the basics. The periodic table has 18 groups, or columns, and 7 periods, or rows. The group 1 elements are typically the most reactive because of their single valence electron. The group 2 elements are known as alkaline earth metals and are also relatively reactive. Groups 3 through 12 are known as the transition metals. Group 17 is known as the halogens and are also very reactive because of their 7 valence electrons. The last group are known as the noble gases, which you guessed it, are composed of gases, which were once thought to be unreactive, but now we know that is not true. It is thought to be unreactive because they have the full octet, or 8 valence electrons. When it comes to oxidation number, the representative elements, or elements other than the transition metals, which are groups 1, 2, 13, 14, 15, 16, 17, and 18, follow a fairly simple pattern. Atoms form bonds in order to fulfill the octet rule, or in other words, to have 8 valence electrons. In order to achieve this, neutral elements become ions and either lose or gain electrons. So the group 1 metals, or the alkali metals, have an oxidation number of +1 because they are in group 1. The elements in group 2 have an oxidation number of +2. Now it gets a little complicated when you come to the other side of the representative elements. Group 13 has an oxidation number of +3. Group 14 has an oxidation number of either +4 or -4. Group 15 has an oxidation number of -3. Group 16 has an oxidation number of -2. The halogens, or group 17, have an oxidation number of -1. And the noble gases don't typically have an oxidation number because they are typically unreactive, but there are a few exceptions. For both the AP and SAT chemistry exams, it is crucial to understand the periodic trends that the table follows. So the first periodic trend you need to know is the atomic radius. The atomic radius is the distance between the nucleus of an atom and its outermost boundary. So the radius increases as you go down, and it decreases as you move to the right. Ionization energy is the amount of energy needed to remove an electron from an atom in a gas phase. Expelling electrons takes energy, and the removal of each subsequent electron takes more and more energy. So the ionization energy, or energy needed to remove an electron, decreases as you move down the table, and decreases as you move to the left, or increases when you move to the right. So finally, we have electronegativity. Electronegativity is essentially a measure of how attracted an atom's nucleus is to the electrons in a chemical bond. A small electronegativity value, such as 0.7 in francium, suggests a very weak attraction to electrons, as opposed to a large value, such as fluorine's 4.0, which happens to be the highest electronegativity value in all of the periodic table. So electronegativity decreases as you move down, and it increases as you move to the right. The periodic table is also divided into 4 blocks: the S block, the P block, the D block, and the F block. Different electron orbitals have different structures, and each atom has a unique electron configuration. The S block, located in groups 1 and 2, has room for 2 electrons. The P orbital, located in groups 13 through 18, has 6 electrons. The D orbital, located in the inner transition metals, has room for 10 electrons. And the F block, located in the lanthanide and actinide series, has room for 14 electrons. And that's all the time I have today. So thank you for checking us out, and I'm always glad to be of help.